So here we've got a quartic equation, and we've been told that one of the roots is equal to minus 2 plus 4i. We've also been told that delta, which is another root, is equal to the complex conjugate of gamma. So we can automatically say that delta is equal to minus 2 minus 4i. Now, since it's a equation where p and q are real, that means that the other two roots have to either be complex or real. So now what we need to do is figure out which expressions we're going to need. So the question actually tells us two more things, which is that alpha plus beta minus 2 are equal to 0, and alpha beta plus 3 is also equal to 0. But we need to show that these are true. Now, in order to show that these are true, we need to see what we're actually dealing with. So here we've got two roots multiplied together, alpha, beta, and we've got a constant number. Now, this obviously can't be the products of roots and pairs case, because if it was, then we would have alpha, gamma, alpha, delta, and so on. So this must be the products of the roots all combined. This first one must be the sum of all the roots together, just normal, because we've got alpha plus beta separate. So we can be smart about this and not actually form all of the equations, and instead only form the ones that we actually need to have. So I'm going to show you a new notation for how you can write out your expressions so that you don't have to spend time writing out all of the different combinations. So we can say that the sum of alpha, where this is just the sum of all the individual roots, is equal to minus b over a, and this is equal to minus 2 over 1. So let me start by just writing out the coefficients. So a is equal to 1, b is equal to 2, c is equal to p, d is equal to q, and e is equal to minus 60. So you can see here that minus b over a is equal to minus 2 over 1, or just minus 2. Now, we know that if we add up our roots, so we have alpha plus beta, and then we add up our two roots we've been given, so gamma and delta, so that's going to be plus minus 2 plus 4i, and then minus 2 minus 4i. Now, I've written this in brackets because this we can simplify. So the minus 2 and minus 2 become minus 4. 4i and minus 4i become 0. This is equal to minus 2, which means that alpha plus beta plus minus 4 is equal to minus 2, which means alpha plus beta minus 2, if we add 2 to both sides, is equal to 0. And that's the first equation that we wanted. Now for the second one, the products of all the roots combined, we can write this as the sum of alpha, beta, gamma, delta. But this is the same thing, so we don't really need the sigma, but this is also a way you can write it. So this is just for your information. This is equal to minus e over a. Sorry, just e over a. So this is equal to alpha times beta times the two other roots multiplied together. So minus 2 plus 4i times minus 2 minus 4i. So this is equal to alpha beta times minus 2 is 4. Then this multiplied by that and this multiplied by that cancel out. So then we're just left with minus 4i squared. Sorry, 16i squared, because it's 4 times 4. And this is equal to alpha beta times 4 times minus 16 times minus 1, because I squared is minus 1, so plus 16, so alpha beta times 20, and this is equal to minus, e over a. E is minus 60, a is 1, so this is equal to minus 60. Now we can say from here that alpha beta times 20 is equal to minus 60, so alpha beta is equal to minus 3, and from here we can say alpha beta plus 3 is equal to 0, and that's what they wanted us to show. Now, the next part of the question wants us to find the values of p and q by first evaluating what the other roots alpha and beta are. So what we can do is we can use the fact that alpha plus beta is equal to 2 by this equation. So let me just write that down here. So alpha plus beta equals 2. Now I can rearrange this equation to get one root by itself. Let's do alpha. So alpha is equal to 2 minus beta. Let's call this equation 1, and let's call this one equation 2. Now I can plug equation 1 into equation 2 and say that 2 minus beta all times beta plus 3 is equal to 0. So that gives us me 2 beta minus beta squared plus 3 is equal to 0, timesing everything by minus 1 and rearranging gives me beta squared minus 2 beta minus 3 is equal to 0. This we can quite easily factorize. So that will give me beta minus 3 times beta plus 1 is equal to 0. So beta is either equal to 3 or minus 1. Now, the funny thing about these types of questions is that there will always be one root where if you plug it back into the original equation, it will just give you the other root. So let's try that. So let's say that beta is equal to 3. So that means that alpha is equal to 2 minus 3, which is equal to minus 1. And that's exactly what the second root gave us. Now let's try beta is equal to minus 1. So beta equals minus 1. So alpha is equal to 2 minus 1, which is equal to 3. And again, that's just the other root. So both of these roots are interchangeable between alpha and beta. So if you pick this one as your alpha, that one will be your beta. And if you pick this one as your alpha, that one will be your beta. So they both can switch around. So we can say any order that alpha is equal to 3 in this case, and then beta is equal to minus 1. So the next part of the question is obviously to solve what P and Q's values are. So for that, we're going to have to use the other two expressions in terms of the coefficients of the polynomial. So those are going to be the products of the roots in pairs and in threes that we didn't use earlier. So the shorthand form for both of those are going to be sigma alpha beta, so the product of two roots or in pairs, and then the sum of alpha, beta, gamma, so the sum of three roots, so in threes. So for each of these, so this is going to be equal to c over a, and this is going to be equal to minus d over a. So first, let's just evaluate what these are going to be in terms of the coefficients. So our c is p, so this is going to be equal to p over 1, or just p, and minus d over a, that's going to be equal to this should be q. So d is equal to q, so this will be equal to minus q. Now, let's evaluate what the actual products are going to be in pairs and in threes. So let's say that the sum of alpha beta, I'm going to write it out just so that you can understand a bit better. This is equal to alpha beta plus beta gamma plus gamma alpha plus alpha delta plus beta delta plus gamma delta. Okay, now let's get all of our roots and multiply them together. So alpha beta is equal to just 3 times minus 1, so minus 3, plus beta times gamma, so that's minus 1 times minus 2 plus 4i, that's going to be 2 minus 4i, and then gamma times alpha, so that times that, 3 times minus 2 plus 4i is minus 6 plus 12i, and then alpha times delta, so 3 times minus 2 minus 4i is minus 6 minus 12i. Then we add, so beta times delta, so minus 1 times minus 2 minus 4i, so that's going to be 2 plus 4i. And then finally we add gamma times delta, so these two multiplied together. Earlier on we saw that that was equal to 20, so let's just do plus 20. Now we can see this minus 4i cancels with this plus 4i, this 12i cancels with this minus 12i. So you can see that the sum of all of these will actually just be a real number. So this is equal, so minus, so let's write this up, so minus 3 plus 2 minus 6 plus 2 plus 20. So this is equal to, so minus 3 plus 2 is minus 1, minus 6 is minus 7, minus 6 minus 13, plus 2 is minus 11, plus 2 is 9. So C, so this is, yes, so that was equal to P, so P is equal to 9. Now, let's do the products of the roots in threes. So that is going to be alpha, beta, gamma sum, and this is equal to alpha, beta, gamma, plus alpha, beta, delta, plus beta, gamma, delta, plus alpha, gamma, delta. So this one might take a bit of a while to do, but if you just make sure you put all your numbers in correctly and expand it out correctly, you won't make any mistakes. So these are our roots up here. So we have alpha is equal to 3, so alpha, beta, gamma will be 3 times minus 1 times minus 2 plus 4i. So that would be 3 times minus 1 times minus 2 plus 4i. Then alpha, beta, delta, 3 times minus 1 times minus 2 minus 4i. So plus 3 times minus 1 minus 2 minus 4i. And then beta, gamma, delta. So gamma, delta, again, was 20. So 20 times minus 1, that will be minus 20. And then alpha, gamma, delta. So gamma, delta is 20. So 20 times 3 is plus 60. So this is equal to minus 3 times this is going to be 6 minus 12i. Minus 3 times this is going to be plus 6, and then that's going to be minus 6 times minus 3 times minus 4i, so plus 12i, and then minus 20 plus 60, so plus 40. So again, this cancels with that, so we're left with 6 plus 6 plus 40, which is equal to 52. And this is our value for minus q. So minus q is equal to 52, which means that q is equal to minus 52. And that's our answer. So again, with these types of questions, you can have shorthand forms for the sums of roots in pairs and threes. And all you need to do is make sure you put all of your expressions correctly in brackets so that you can expand it out correctly. And you should be able to form an expression for your coefficients in terms of the numbers that you've been given previously.